Welcome to Rhythm Timeline 2 video series. In this one, we're going to have a look at the VR demo. So the first thing you'll want to find is under Dipsloom Rhythm Timeline Demos, you'll find this package over here that you can open. But before we open it, we want to download certain packages. We'll go under Window, Package Manager, and we'll search for Meta. The demo was built on the MetaQuest 3. And this is the only device we officially support. So you'll need to open those packages because they are used inside the demo scene. So we'll first install this one, OpenXR Meta. This might take a moment to install. In the meantime, you can check out the documentation for OpenXR Meta. It has a few things that are very important to know how to set it up, etc., etc. What can be enabled, what can be disabled. Another thing you can do is if you have your device already set up, or at least opened up, etc., you can go inside the Meta Horizon dev documentation, and you can learn how to set up your MetaQuest headset for development. So I'll link all of these things inside the description, and it's also all documented in the documentation of Rhythm Timeline 2. So we're back in Unity over here. We've got our project settings. It's been installed. Another thing you'll want to install is, if I can just close this, we'll want to install the XR Toolkit. Let me see if I can find it. Toolkit, XR Interaction Toolkit. This has a few prefabs that we're using in the demo scene. Okay, so this is now downloaded. We're gonna close everything, check our console. Everything seems to be fine, and we're gonna open the OpenXR VR demo scene for Rhythm Timeline. Let's import. Okay, so it's been imported. It seems there's been some problems over here about something that's missing. Let's have a double check. So it seems a few prefabs are missing, probably from the packages we just downloaded. But let me see. I think it's simply because inside the package manager, I forgot to check the samples. Let's see. Does it work now? Let it compile. Got this that opens up. Okay, it says that our starter scene teleport is missing. And just fix. We close it again. Come back to our VR scene. We go to Assets, Dipsloom, Rhythm Timeline, Demos, OpenXR. And if we now go to, which one is it? This one. This is our demo scene. Okay, it seems that now everything has been fixed. Let's double check. Yes. It seems that now all of our prefab are correctly connected. So this is the demo scene in question. We got a few components, but the gist of it is we got the XR origin rig, which comes from the sample scene that we just downloaded. And inside of it, under the left controller, we've got our sword left and sword right. Okay, so we've got everything sorted out. Now let's see if we can connect our MetaQuest to Unity. So if you haven't installed it yet, I really recommend you install the MetaQuest link. over here, it says that it's not connected. So let me see if I can connect it really quickly. So it seems that I've forgotten one step, which is to go under File, over here, Build Profiles. And once I open the Build Profiles, make sure that I go under Android. I'm going to switch the platform. This will ensure that when we press play inside the editor, we should be able to see it inside the MetaQuest. I'll give it some time to install. Okay, over here, we're going to add our OpenXR VR scene. We'll add the scene over here. We'll go back to our Android to make sure that everything is set up correctly. Okay, so we're back over here. Let's see how I set up everything. So I got user player settings, should be fine. Default device, let's see if we can find our Oculus. So we can see Oculus Quest. To ensure that the play button allows you to play directly on the MetaQuest 3, what you'll want to do is make sure that you've got your settings the way I have them here, which is have the Android build and the Windows build. You'll want both of them to have the OpenXR setup. In this case, the MetaQuest feature group also in the Android one. Once you have both of those clicked and it's going to compile some stuff, you'll want to go under OpenXR and you want to make sure that you add in here with this drop down over there of these profiles. So it's Oculus Touch, MetaQuest Touch Plus, MetaQuest Touch Pro, and these are the features that I've got for the MetaQuest. So support, anchors, etc., etc. And on the Windows one, you also want to have the same thing, Oculus Touch, MetaQuest, and you can also have your play mode OpenXR runtime be the system default. And normally, if you've got this set up and you've got your MetaQuest that is currently active and connected, then it should be fine. In this case, you can see that mine is. So now I'm going to see you on the device. So I'm now in the MetaQuest preview. I'm actually recording the audio separately because turns out I've recorded the game audio and that caused a few issues with the sound being way too loud. So I'm currently now in MetaQuest link. I'm pressing the play button in Unity and it automatically plays the game. I'm now in the VR demo. If in here I'm back in the MetaQuest, if you press the button to go to the menu, if you hover over the time, you'll see there's this reset view button. If you press it, then you're able to reset the view. In this case, I'm trying to reset the view such that the floor is in the correct place. Because I didn't set the boundaries, so I'm just doing it again. And now it's a much better position. So here we've got the Start Welcome panel. We can press Start. And we get to our song chooser. And here we've got the same as the other demos. We've got 2 songs. We've got our high score, etc. So we can see the lights are being set up. So they're animated with the timeline. And at the same time, we can cut through the notes. We're using a asset called Easy Cut, or Easy Slice, sorry, for cutting the notes. It's an open source package. There's red notes that are supposed to be hit with a red sword. Blue notes are supposed to be hit by the blue sword. We've got those yellow dodge notes that we need to dodge with our head. And the mines that we're supposed not to hit. If we hit a mine, we get a bad. If we hit red notes with blue sword, we get bads. If If we miss notes, then we get misses, etc. It all works as you'd expect. The way we detect how we slice the blocks is actually with raycasting. We're doing some raycasting interpolation, so that's within a single frame we're recasting multiple times in all the previous positions that the sword was in and in between the positions. So I'll explain this in more detail once we're back in Unity. We're now back in Unity, and we're going to have a look at how this has been set up. So over here, we've got our XR origin with all our controller setup, etc. This is all basic MetaQuest stuff or OpenXR stuff. What we're really interested in is more our own custom stuff for Rhythm Timeline. So if we go to our director over here, we'll notice by going to 3D mode that we have our notes over here, and we can see them going towards the player over there. So how do we set these up? Well, similar to how it's done for the OSU demo, what I can do is go over here. We've got our note. Let's go in maybe 2D view, and then we can move our notes. So let's say this one, we can move it. You can see here over in the game view as we move it top left, etc. And move it around, and it gets moved directly over there. So we can set up its position, and then if we want to make it closer, a bit back. So fairly simple on how this works. We've got our mine nodes. So these are the black ones that we shouldn't hit. And then if we check below inside our timeline, we'll see that we have more tracks. What does that mean? Well, we've got already 3 tracks for the basic notes and the mine notes. The reason we have those tracks is essentially such that we can cram up more notes closer to each other. We could easily have them all into a single track, but this makes it more easy for us to organize things. But then we have these other tracks, and the reason we have those is for the dodge. And the reason we've set those separately is because the notes, these ones, they're meant to be spawned in a specific position. So you'll notice how we're using the same dodge note over here, but some of them are vertical and some of them are horizontal. And the reason for that is if we check our tracks, we'll notice that our left track is rotated by 90 degrees and our right one also, and the center one is not. And we've set up our dodge nodes. We check inside our project to orient with the track. Let me find my dodge block. Here's my dodge block over there. And as you can see, it's set up for orient track. So it rotates to the direction of the track. And that's why we've set it up to be separately. One other thing is also the notes are being spawned at the position of those tracks. So in this case, you can notice how this one is on the left. This one is, this one is on the left. This one is on the right. This one is in the center. And that's how we've set it up. And if we go back to our rhythm director, we can see how those, even though they have a 0, 0 position or vector 2, that it's on the left. Of course, we can move them if we want to, but it gives us a base position to work from, right? Let's have a look at the VR nodes in more detail. So we'll just click on one on our blue VR node and find our prefab. What is a VR node? There's 2 different VR nodes. There's this one, which is the VR rhythm sliceable node. And this component, what it has is something that allows us to miss on deactivate, which is essentially, for example, the dodge note was at this to false because we don't want to get a miss if we're able to dodge it. We can say whether if you hit the note with the wrong hand, in this case we've got a blue hand and a right hand, if we get a bad or if we get an ignore or if we get a good, here we can define which one is good, which one is bad. So we've got an index 1, 2, and 0. So 1 for good, 2 for bad, and 0 for ignore. 0 is the head, 1 is the left hand, I believe, and 2 is the right hand. We can double check that if we go over here inside the scene and we find our hands, which should be in here, the camera. We've got our right controller and left controller and our left sword. So the left sword has a VR rhythm input slice trigger. So this is what we use to slice the notes. And we can see over here that has an index of 1 for the blue sword, and the right sword has an index of 2. And if we check the head, which should be under the main camera, we'll see that this one is a rhythm input collider, which is different from the Raycast one, which is an index of 0. So the head, all it does is tell you if you've triggered it with a collider. So if your head enters a collider, you get a hit. And these ones for the sword are slightly different. What they're going to do is they're going to use a raycast that we can have. For example, over here, we can notice that I have a ray interpolation extra sample count. The way it works is you'll have your sword be in a position 1 frame, and then perhaps you moved it very, very fast, and the next frame it's all the way over there, right? So what we want to do is we don't want to miss a cube when we do this. So what we do is we hit a raycast from the previous frame, we do a raycast to the current frame, and then we're going to do a lot of raycasts in between those 2 frames. And these are what the ray interpolation extra sample counts are all about. They're essentially going to tell us how many rays we can do in between those 2 positions. And this is very useful because, as you can imagine, we're going to move very, very fast, especially with those swords, and want to be able to detect and not miss any notes. So if you notice that you're missing quite a few, then perhaps you can crank up that number a bit higher, but of course don't overdo it because otherwise it might be too much. What else can we have a look? We probably want to have a look at how this input is set. So we've got our input slicer, but to make sure that they're actually taken into account, we've got to check how our VR rhythm input manager works. So as similar to the OSU demo and the normal demo scene, we've got our director over here with our rhythm processor and our input manager. And in this case, the input manager is a VR rhythm input manager. And all it does is have a list of our left sword, right sword, and head. It's as simple as that. Everything else is handled by the rest. So we've seen our blue note. Let's have a look at our mine note over here. So in this case, what I've got is that if you don't hit it, you're not going to get a miss, which is perfect. If you do hit it, you get a bad, and you get a bad if you hit it with the left sword or the right sword, but it ignores the head. It's as simple as that. One thing you need to take into account is for the mesh slicing. So the mesh slicing, the way it works is we're using an asset, which is a open source package or library that you can find on GitHub. It's called Easy Slice. And what it does, it essentially allows us to cut those meshes in a very simple way in a few lines of code, instead of having to write a custom system just for this demo. But the way it cuts the mesh, it requires the mesh data. So for that, what you'll need is very important is whenever you have a model, for example, in this case, the Mind VR, you need to make sure that this mesh is writable. What does that mean? You need to find the mesh inside your project, select it, and over here inside the settings, there should be a setting somewhere, if I remember correctly, about being able to read and write, which is over here. Read and write. This needs to be ticked on. Otherwise, the system of Easy Slice cannot read the mesh data, and we're not able to cut those meshes. So you'll just hit them and nothing's going to happen. Over here, we've got a few other settings. For example, when we slash the mesh, we can decide what kind of material gets assigned to the sliced area, and we can also assign some force. Of course, you can add more stuff if you want to make a custom note and inherit from this class. You can add some event receivers if you want to add some special effects, some audio, some particle effects, etc., etc. So this is for the VR rhythm sliceable nodes. Of course, it only detects input for the input with the VR input slice trigger. For the other node, which is the dodge node, it doesn't use a slice. Instead, it uses a VR rhythm trigger node. And this one, very similar to the other ones, we've got our goods, our bad, and our ignores. So in this case, we're going to ignore the swords, but we're going to get a bad if we hit the head. And it uses the trigger, so it's going to be able to work with our head, which is just a VR input collider trigger. And that's essentially it. It's fairly simple once you've got the thing set up, but you can take it much further away if you want to improve on it. If you want to add more stuff to this demo, it's just a very simple, so it's a place to start and for you to build upon and make something very unique for you. One thing I can recommend is in the case of the first song, for example, if we scroll down and we check over here, you'll notice that I have a bit more stuff inside the environment. And these are just for the lights. Let me just move this over here. And we'll check the lights over there. And you'll notice how they move around. And there's just a very fun thing with the timeline is you can really sync whatever you want with the song. And in this case, we just synced the movement of these things that they get slightly one more, they get activated, and then with the song they just move left and right. Of course, this animation you can make it much more complicated than we did, but this is an example of how you can sync animations with your nodes in a very interesting way. I believe that's all I wanted to show for this demo scene. If you got any questions, then make sure to let me know in the Discord or through email or however you can find me. I'll see you in the next one. Bye-bye.